Okay, so we were seeing this example, that is x of n is equal to half raised to n u of n, and I reached this point. So this was the point where we reached, that is n tends to infinity, n is equal to 0 to n. So this was because u of n, because of the influence of u of n. U of n starts at n is equal to 0, it extends up to plus infinity. That is why this whole summation, even though it is from minus n to capital N, it suffices from 0 to n. Okay. So this is the thing. Okay, now this is a geometric progression, that is, just listen. Summation from 0 to infinity, a raised to n is equal to 1 by 1 minus a. Remember, geometric progression is in this form, that is, summation from 0 to infinity, a raised to n equal to 1 by 1 minus a. So what is a here? A here is 1 by 4. So substituting that, 1 by 1 minus 1 by 4 is nothing but 4 by 3 joules. So energy of a signal is having a finite value 4 by 3 joules. Now what about power? So power is nothing but, by definition, this is the equation for power, that is limit n tends to infinity 1 by 2 n plus 1. This is the equation. Substituting it here, so 1 by 2 square the whole 1 by 2 the whole raised to n, the whole square, that becomes 1 by 4 the whole raised to n, just like this. This is another geometric progression. Okay, that means this is in the form of that is 1 by 2n plus 1, a summation 0 to n, 1 by a raised to n, where with limit n tends to infinity is nothing but what, 1 by 2n plus 1 multiplied by 1 minus a raised to capital N plus 1 divided by 1 minus a. So this is a. Instead of a, we can substitute 1 by 4 here. So in this form, if the expression is in this form, you can use the geometric progression of equation, that is 1 by 2n plus 1, 1 minus a raised to capital N plus 1 divided by 1 minus a. Okay, and if you substitute that and if you apply the limits, the whole thing becomes 0, because here you have the value of n. If n tends to infinity, the whole thing raises to 0. The whole thing goes to 0. So this is an energy signal. Why? Because power is 0 and energy is a finite value. Okay, now here is another thing, another important thing, that is, this is in the form of e raised to j theta, where theta is nothing but pi by 3 n plus pi by 2. Theta is nothing but this whole thing is theta. Okay, so what is the magnitude? I am taking the square of the magnitude. What is the magnitude of e raised to j theta? Magnitude of e raised to j theta is 1. Why? E raised to j theta is nothing but cos theta plus j sin theta. Theta can be any value. Okay, so cos theta plus j sin theta magnitude is nothing but root of cos square theta plus sin square theta. You know what is cos square theta plus sin square theta? Cos square theta plus sin square theta is nothing but 1. Root of 1 is nothing but 1. So the magnitude of e raised to j theta, theta being any value, is 1. So 1 square within these limits of summation, where with n leading to infinity. So if you perform summation of 1 infinite number of times, because why I am telling that infinite number of times, because n is going to infinity. So if you perform such a summation of 1 is added infinite number of, in fact double infinite number of times, the whole thing becomes what? Infinity. Now what about the so energy is infinity. So what about power? Power is nothing but see, by definition this is the case. Again, summation is of double summation of 1. So but one thing happens when you perform summation, because since here there is a factor of 1 by 2n plus 1, what is happening inside is very important. Okay, so 1 get added to 1 get added from -1 to -n. Okay, that is 1, that is n number of times it is get adding in the negative side, and n number of times it is added in the positive side, that is from 1 to n plus n times it is adding n times, and in between you have a 1, that is at n is equal to 0, because from -1 to n, from -n to -1 you have n number of samples, capital N number of samples. From 1 to n you have another capital N number of samples, and in between you have n is equal to 0. So how many samples are there totally? So how many times you are adding 1? You are adding 1 to n plus 1. So what is the result of the summation? It is nothing but 2n plus 1. So that 2n plus 1 and this 2n plus 1 gets cancelled. The result is that it is 1 watts. Okay. So similarly, you can just try these problems. Okay, everything is very simple. Okay, here you are using the identity of sine square theta, which is nothing but 1 minus cos 2 theta by 2. Okay, so if you add again the same, if you open the summation, here you have infinite summation of this one with n. So what is the result of that? 2n plus 1, that and that gets cancelled. You have, and what about this one? This one is nothing but cos 120, cos 120 by 2, that is cos 60. Okay, so so the whole thing will have a value, what, half watts. Okay, now okay, now you can do all those things and see what is happening. And this is another example, that is n into u of n. Okay, and you can try all those things. Okay, I'm leaving to the next portion where we have to learn about what is a causal signal and non-causal signal. What is a causal signal? Causal signal is having, if x of t is causal, it is having 0 value for t less than 0. For from -1 to minus infinity, for negative values of time, you have signal value 0. Okay, that is what is example of a causal signal. That is a continuous domain. And what is anti-causal signal? It is having values only for negative values of time, that is, it is having value 0 for t greater than 0. Okay, and similarly you can, so what is a perfect causal signal? U of t is a perfect causal signal because it is having only values from 0 to plus infinity. Okay, and u of minus t is strictly anti-causal because it is having only values from 0 to minus infinity. Okay, now similarly you can have it for x of n also. X of n is nothing, x of n is causal if it is having values equal to 0 for n less than 0, and if it is causal, non-causal, it is having values only for n less than 0, and for n greater than 0, x of n is equal to 0. Okay, now we'll see some examples of that. So these are the examples. We'll see few examples. Okay, just look the question and we can just write whether it is non-causal or causal. Okay, this one, what is the value? E raised to 2t u of t minus 1. What is the result? The result is that u of t minus 1 starts at 1 and extends up to plus infinity. So this signal is strictly a right-sided sequence. It is only having value at positive values of t. So multiplying such a signal with e raised to 2t, the whole thing becomes a causal signal. Okay, likewise this one, what is u of u minus t plus 2? U of minus t plus 2 starts at what? At the point minus t plus 2 equal to 0, that is minus t equal to minus 2, that is t is equal to 2, minus t equal to minus 2, that is t is equal to 2. Okay, so what happens? It is actually a non-causal signal because it is having value for negative values. X of t is not equal to 0 for t less than 0. So what happens? So it starts at 2 and extends up to minus infinity because this is a flipped signal. This is a reversed signal. Okay, it starts at plus 2 and extends up to negative infinity. So this is a non-causal signal. Okay, now what about this one? That is u of t plus 2, u of t plus 2 and u of t minus 2. What is the value? U of t plus 2 is nothing but it starts at t is equal to minus 2 and extends up to plus infinity. Plus infinity. And what is u of t minus 2? It starts at plus 2 and goes to this one starts at minus t is equal to minus 2 and extends to plus infinity, and this goes from this starts at plus t is equal to plus 2 and goes up to minus infinity. So what happens when you do the this subtraction? What is happening is that you will have a signal of height or magnitude 1 from t is equal to minus 2 to t is equal to plus 2. So you have values from minus 2 to 0 and from 0 to plus 2. So the signal is a double-sided signal, that is, it is having values both at negative and positive. So that's a strictly non-causal signal. Now this cos 2t is another thing. Cos 2t, that is, it's not the signal has values for negative values of t, so this is a non-causal signal. Whenever you see u of t being multiplied with any signal, that becomes a causal signal because u of t is a signal which starts at 0, t is equal to 0 and extends up to plus infinity. Okay, likewise you can solve all the problems. Okay, now we are moving to the next classification called even or odd signals. So what is even signal? Even signal is called an asymmetric signal, and odd signal is called an anti-symmetrical signal. Why it is called? Because I just show. So x of t is said to be even if it is equal to x of minus t for all values of t. X of t is equal to x of minus t for all values of t. For example, if we take this signal, it's a cosine waveform. See, a value at this point, this is a negative value of, suppose this is a negative value here, and this value is equal to the value at this point. So the value at this negative instant of time is equal to the value at the positive instant of time. Okay, or the value here at the negative instant of time is equal to the value here at the positive instant of time. So you can see that it's a mirror reflection. That is how this definition holds good. X of t is equal to x of minus t for all values of t. So strictly cosine waves are even signals. And similarly, you can tell that for discrete time signals also, that is x of n is equal to x of minus n for all values of n. Okay, so what is that? That is these are all examples of even signals. This is example of a discrete time even signal. That is, what is happening at 1 is also happening at minus 1. That is, this is a mirror, just like a mirror. What 1 is being reflected here and 2 is getting reflected here at minus 2. Okay, mirror reflection. Okay, and what is odd signal? Odd signal is nothing but, that is, this is here by definition. Odd signal is nothing but x of t is equal to minus x of minus t for all values of t. That is for continuous. X of t is equal to minus x of minus t for all values of t. And similarly for discrete time, it is x of n is equal to minus x of minus n for all values of n. That is, the signal is anti-symmetric with respect to the vertical axis. Anti-symmetric with respect to vertical axis, whereas even signals are symmetric with respect to vertical axis. And you can see the waveforms. That is, cosine waves are odd waveform. That is, at this point, suppose here you have some values of negative values of t. This value of negative value of c, you have a value negative peak here, but correspondingly for the same positive t value, you have what? The magnitude which is positive. This is minus Vm, but here it is plus Vm. But suppose t is equal to half here, and so t here is minus half. At t is equal to minus half, suppose we have plus Vm here. For t is equal to plus half, you have plus Vm here. That is how this definition. So this is anti-symmetric with respect to the vertical axis. Similarly, you can see for x of n also. That is, what is happening here? It is a positive value at 1. What is happening at negative value is the reverse of that. That is, negative value of this one is coming at minus 1. Similarly, at 2 you have a positive value. The same positive value turns negative value at minus 2. That is how you write this definition. That is, even odd signals are x of t is equal to minus x of minus t for all values of t, and for discrete it is x of n is equal to minus x of minus n for discrete time signals. Okay, now a signal in general may be even, may not be even and odd. Yes, there can be signals which are neither even nor odd, but any signals can be expressed as a summation of even and odd. Okay, we'll see that is, any signal x of t can be written as two components, that is, even component and odd component. Okay, and this is the starting point. We substitute, instead of t, we substitute t is equal to minus t. So x of minus t is equal to xe of minus t plus x naught of minus t. We know that even for e, from the definition, xe of minus t is equal to xe of t, and from definition of this one, x naught of minus t is equal to minus x naught of t. Okay, substituting that, we'll get this equation. Okay, and we perform the summation of these two. So x of t. So what happens when you add these two equations? The odd component gets cancelled, and what you get is what? 2 times xe of t. That is, xe of t is nothing but half x of t plus x of minus t. That is the even component in the signal x of t. Similarly, if you find the difference between x of t and x of minus t, you get that even components gets cancelled and odd components get added. That is 2 times x naught of t. So what is x naught of t? X naught of t is nothing but half x of t minus x of minus t. So these are the even and odd components.